Well, that haze in North America comes as scientists officially confirm that an El Niño weather event has begun. The naturally occurring phenomenon sees warmer water come to the surface of the Pacific Ocean. It pushes heat into the atmosphere and it affects weather all over the world. The researchers say the latest event is gaining strength and could lead to record-breaking temperatures next year. So let's speak to our environment correspondent, Matt McGrath, who's in Cardiff for us. And Matt, just explain the significance of this official confirmation that El Niño has begun.
That's right. Scientists for months have been speculating, growing in confidence that an El Niño event, which happens naturally every 2 to 7 years, was about to form in the Pacific. And today we've had that confirmation coming from the US scientists saying it is actually happening. It's met the threshold for their criteria to declare it, and they're declaring it, and they believe it'll get stronger. It'll run possibly till next spring, and it will have a significant range of impacts around the world, including possibly driving up global temperatures next year to record levels.
And we're expecting that this will create more of these sorts of images we're looking at on the screen: floods, droughts and extremes of weather. And I'm looking at some of the notes, particularly in winter. That's when it might be at its worst.
That's right. It will be winter when it gets to its peak of the El Niño. It has different impacts in different parts of the world. It tends to make Australia drier, Asia drier, impacts the monsoon, impacts rainfall in southern US states. So it has a variety of impacts around the world. But the likelihood is we will see more storms, we will see more droughts, and we will see likely more wildfires connected indirectly to a globally warming world. The bigger impact, I think, is the fact that this will push up a lot of energy into the atmosphere, and that will drive up global temperatures, and it's likely that next year will be a record year. It could even get close to the 1.5 Celsius temperature threshold that was agreed at Paris by politicians, albeit temporarily. It could push us close to that, which I think would be quite a significant moment and would give us a glimpse perhaps of the climate in the future if the world continues to warm in this way.
Inevitably, people will make the connection with climate change, but is this a naturally occurring phenomenon, one that is just made worse by a warming climate?
Absolutely. It is a naturally occurring event, and there have been about 25 of them or so over the last century or so. What's really different this time is that the warmth in the seas are at record levels of warming. Normally an El Niño comes along and it pushes up the temperature in the seas and then into the atmosphere. But right now the El Niño is coming on top of record warm temperatures, and scientists say literally we are in uncharted territory. We do not know what that will mean. Having this much extra heat come into the atmosphere from already warm waters, we could see significant impacts that we just don't know what they are just yet.
Matt, really good to have that explanation. Thank you, Matt McGrath there in Cardiff. Well, let's talk to BBC Weather's Chris Fawkes. And Chris, you've got some really interesting charts behind you there. Just explain a little bit about what they show, because Matt was explaining this is naturally occurring, but nonetheless it could have huge implications for our weather right around the world.
Yes, it could have in the months to come, Ben. You're dead right. And El Niño is where we get the warm waters across the tropical Pacific Ocean, this part of the world. And you can see these red colours show that temperatures are indeed above normal. That's why the Americans have been the first to declare that an El Niño is underway, although they do talk about the signal being quite weak. There are other Met agencies, for example, the Bureau of Meteorology in Australia and the Japanese Meteorological Agency. They reckon we're still in neutral conditions. They are forecasting it to become an El Niño, but there are some things in the atmosphere that aren't quite linked in at the moment. The winds aren't quite right across the Pacific, and we've still got some quite warm waters in the west, which you wouldn't normally see in an El Niño. But that said, all agencies are expecting an El Niño to arrive. It's just that the Americans have said it's arrived today.
Chris, just explain that point I was talking to Matt about why we feel this more in winter, and it's to do with the pressure systems being stronger, isn't it? Just explain that if you can.
So it affects the whole planetary circulation via something called the Hadley cell, which kind of moves around, and it moves which parts of the planet see wetter than average weather. For example, over the last few weeks we've seen some torrential rain in Ecuador here, and that's brought some severe flooding. Same true across Peru. And around the coastline of South America, temperatures in the seas have been 6 degrees above average over the last month, and that's been just pumping extra moisture into the atmosphere, and that is a classic kind of El Niño signal. One of the other things that we can see is much drier weather across Southeast Asia, and this can often really result in more significant wildfires affecting parts of Indonesia, Malaysia. Sometimes we see stories of the smoke drifting across this part of the world and affecting Singapore as well. So there are global impacts from an El Nino event. Some of the other bits and bobs, well, at the moment, the National Hurricane Centre is forecasting an average Atlantic hurricane season. But in El Nino years, actually, there tend to be fewer hurricanes in the Atlantic. The reason being there's more wind in the atmosphere. And the one thing that hurricanes hate, ironically, is wind. Kind of blows over the circulation, stops them developing. But at the same time, those warmer waters in the Pacific Ocean tend to produce more storms. So you tend to get more typhoons and more hurricanes in the East Pacific Basin and fewer hurricanes in the Atlantic Basin.
Hurricanes hate wind.
They do. It's one of life's ironies. They kind of work like chimneys, sucking up the energy from the warm seas underneath and then blowing out the winds at the top of the storm system. But these winds kind of blow the hurricane over, and so you don't get that nice circulation. There's not a feedback effect, and pressure doesn't fall as quickly, so you don't get as many of these hurricanes forming in the Atlantic.
Chris, that's fascinating. Thank you for explaining that. It really does underline how it's all interlinked, doesn't it? Really good to see those charts as well. Chris Fawkes there from BBC Weather. Thank you.